Hi student, welcome in chemistry classes. Now the chapter is P block element 2. The topic is chemical properties of nitric acid. In our previous video, two chemical properties discussed like acid behavior and oxidizing agent. That means nitric acid acts as a good oxidizing agent. So now another property is action of nitric acid on metal. That means metal to react with nitric acid, what happens? That's why generally all metal react with nitric acid, but some cases exceptions like platinum, gold, rhodium, iridium, tantalum. These are the elements do not react with the nitric acid. Okay, so first important point. Then next, nitric acid oxidized the metals. Nitric acid is oxidize the metals. That means metal is easy to oxidize. That means a higher oxidation is called the lower oxidation state. So next, aluminium, iron, cobalt, nickel and chromium. These are the more important element. That means a D block element are rendered passive in concentrated nitric acid. Rendered passive in concentrated nitric acid. That means these are the element like chromium, aluminium, cobalt, nickel do not react with the concentrated nitric acid or do not give the any product for concentrated nitric acid, because these are the metals to formation of the layer, metal surface to formation of the oxide layer. This oxide layer is a protective for this metal, so do not to react with concentrated nitric acid. That means a concentrated nitric acid do not react with concentrated nitric acid. Okay, so it's a prevent the nitric acid from the reacting for the pure metal. Very important for the pure metal. But sometimes impure metal may be react with concentrated nitric acid. So more important, why concentrated nitric acid do not react with aluminium, iron, cobalt, nickel or rendered in passive? That is a question. So single word answer, very simple. The formation of the oxide layer from metal surface. Oxide layer from the metal surface. It is a more important question. So that's it. Then next, weak electropositive element is present. Okay, like tin, arsenic, antimony, tungsten, molybdenum. These are the weak electropositive metal to react with nitric acid to form the metal oxide. So here is a metal is a higher oxidation state to is converted to the lower oxidation state. Like that. Here nitric acid is a plus 5, plus 4, plus 3, plus 2, plus 1, 0 also minus 3. This is a lower oxidation state is a converted also. Then nitric acid to react with the metal, generally two type of the general product is give, that means a common product is a questionable product. That means sometimes it is also sometimes to produce. Okay, so most of the cases or most of the reaction, nitric acid to react with the metal to form NO2 nitrogen dioxide and nitric acid and water, it is a common. Most of the reaction give for this type of the reaction. Some reaction also give N2 NH2H nitrogen and then NH2H hydroxylamine, also ammonia, sometimes they give. Okay, also here the various oxidation state are given for the nitric acid, nitrogen dioxide, nitrous acid, nitrogen dioxide, N2O, N2 and then NH3. Okay, so these are the general, that means react with the nitric acid, react with the metal. Also 3 steps involved in nitric acid reaction with the metal is the most important. That is the equation type. So type in primary reaction, secondary reaction and tertiary reaction. These are the 3 steps involved nitric acid to react with the metal. So discuss one by one. What happens metal to react with the nitric acid? So primary, secondary, tertiary. Okay, let us now start. So nitric acid to react with metal, the following steps are involved, already said. So primary, secondary, tertiary. So first primary reaction. So metal to react with nitric acid to form metal nitrate to produce for the hydrogen, that is called a nascent hydrogen. That means a single hydrogen. Okay, this hydrogen, this nascent hydrogen to react with a secondary reaction. So nitric acid to form the nascent hydrogen to form nitrous acid, HNO2. It is called a secondary reaction. Suppose you excess of nascent hydrogen to produce for hydroxylamine. Also further high nascent hydrogen to produce for the ammonia. So already I say nitric acid to react with the metal, two types of product is obtained. Generally NO2, NO and water, and then sometimes NH2OH, ammonia and also N2 for here. So ammonia, NH2OH is produced for the sometimes a reaction. That means excess of nascent hydrogen is produced. That's why. Okay. So further nitric acid hydrogen to form H2N2O2 and then 4H2O. These are the secondary reaction. So primary reaction, nascent hydrogen is produced. Secondary reaction, nascent hydrogen to react with the nitric acid to form the formation of the compounds. Also tertiary reaction, there are two types of the reaction. One is a decomposition of secondary, also reaction of the secondary product. That is the main important, the tertiary reaction. So tertiary reaction to decide the product. What is the product? That means a metal to react with nitric acid to form the product is a decide tertiary reaction. Say here to form the, suppose nitrous acid HNO2. I take this only for the nitrous acid. HNO2 to produce nitric acid, NO and then water. Suppose excess HNO2 to produce N2O3 and water. Also H2N2O2 to produce the NO2. So these are the decomposition of the secondary reactant. Also this secondary reactant to form the product. So HNO2 form N2, HNO2 react with hydroxylamine to form N2O, dinitrogen oxide, HNO2 form the nitric acid to form nitrogen dioxide, NO2. So these are the three steps involved for the reaction with metal for nitric acid. Okay, I give for the one example. Generally overall three steps for the one example is given. So example, copper to react with nitric acid. Two different types of the nitric acid. One is a dilute nitric acid, another is a concentrated nitric acid. Here copper to react with a dilute nitric acid at 8HNO3 to form copper nitrate. It is a salt is a produced, CuNO3 twice copper nitrate salt. Also to produce a NO nitric oxide, NO is a produced, not for the NO2. NO is a produced, more important. NO for dilute acid. Dilute nitric acid produced, NO is a produced for the water. Suppose it may be to react with a concentrated nitric acid to react for the suppose concentrated nitric acid to produce for the NO2 gas. It is a more important. Dilute acid to produce a NO gas, also concentrated acid to produce for the NO2 gas. So this overall reaction for single reaction, how to convert copper to react with nitric acid to form the product. So following the three steps are involved. First, copper to react with the nitric acid. 6 moles of nitric acid to produce copper nitrate, also nascent nitrogen is produced. These are primary steps like that. Here the primary step. This nascent nitrogen to react with the nitric acid like that. Secondary reaction. Nascent nitrogen to react with the nitric acid like that. To nascent nitric acid to form nitrous acid like that. This tester, this nitrous acid, any one of the following reaction. So decompose like that. This nitrous acid is a decompose HNO2 for the NO. Suppose N2O3 sometimes obtained, but I take for the HNO2 to form the NO. These are the primary, secondary, tertiary reaction. So these are three steps reaction. Overall reaction I have had reactant side and product here totally. Here I can say cancelling. So 3 copper is a present. I can write for the 3 copper. 6 HNO3 plus 3 HNO, totally 9 HNO3 is present, but here 1 HNO3, here 1 HNO3 is cancel, is remaining is present. 3 HNO2, 3 HNO2 is cancel also 6 nascent hydrogen, 6 nascent hydrogen is cancel. Upon remaining what happens? So copper plus 6 HNO3 plus 2 HNO3, because here 1 HNO3, here 3 HNO3, totally is remaining 2 HNO3 is obtained. Also gives CuNO3 twice 3 H2O plus H2O, also 2NO. So adding 3 plus 2, 8. So 8 nitric acid, 3 copper, also copper nitrate, okay, 3 NO2, 2 NO, here 2 NO is obtained, 4 H2O, 3 plus 1, 4 H2O. It is a overall reaction, that's all. Okay, so it is a example for copper to react with nitric acid. So another one example, magnesium to react with nitric acid, you do. Okay, student, thank you.